Now our topic is 12.2 electric potential and potential difference. Before we are going to learn what is electric potential and potential difference, let us know something about the flow of charge inside the wire. How does a metal conduct electricity? You would think that the low energy electron would have great difficulty passing through a solid conductor inside the solid. The atoms are packed together with very little spacing between them, but in terms of the electrons are able to travel through a perfect solid crystal smoothly and easily, almost as if in the vacuum. Look here, this is a copper wire. Now we are applying electric field across this copper rod. The copper rod have a lot of electrons and protons with this. Now the word flow of charge means only electron will flow through this circuit. Proton will not move. Protons are inside of the nucleus, but whereas the electrons are revolving around the nucleus in the orbit. See what happens when we apply electric field is not that physically this electron crosses through the conductor and reach the positive terminal, not like that. Once we apply electric field across the two terminal, either this electron will reach here, then this one will supply, this will reach. So electron will make a path through this direction. It will supply this a negative terminal is having a lot of negative charges. This has a lot of positive charges. This will supply electron. This will receive electron. Here will be more positive charges. Here will be more negative charges. When you apply not physically this electron, which is here. Once we apply the electric field when we connect it like that, the positive terminal is connected with this copper rod. The negative terminal is connected with copper rod. Once we apply this connector like that, the electron will start to flow in this direction. It will supply electron and will receive. The speed of the electrons is, and you have for small current, 0.1 centimeter per second or 1 millimeter per second. Look at this book, you will understand. See, one. Huh? Now we can see in another book. See, the battery has two terminals. One is the positive, other negative. The positive terminal is connected. This is a copper wire. It is connected at one end, and the negative terminal is connected at the other end of the conductor. Now you pause this video and go through this definition. Drift velocity and mobility. Okay. See. Look at here. This is drift velocity. Drift velocity is equal to E. This is the charge of one electron. This is E is the electric field, mass of one electron, and T is the average time between two successive collisions, because the electron will get collided. It will not smoothly move. The electron will get collided because when it moves, the positive nucleus has the positive charge will attract this electron. So it will move. It will be attracted. Then this positive terminal will attract the electron with some sort of acceleration. Then it will start to move in this direction. Okay, that's what I have explained. You just pause this video and learn about it. See, they have given, and the speed is given in 0.1 centimeter per second. Okay. See, now you are looking the picture of the earth. Here a man is standing like that. Here one man is standing like that. You may think that they will not fall because the gravity of the earth is attracting each and every objects on the surface of the earth. So you don't think like that. See, this is the earth. This is the earth. Earth is attracting every objects around this space found here. Okay. Now I am going to introduce what is the electric potential and potential difference. Before we are going to learn about electric potential and potential difference, I want to give an analogy of a mass, and now I am going to compare mass and charge here. See, this is one mass, this is one mass. Now let me read this table. Here I take a quantity mass. Now I take the here I take the quantity of charge. The unit of mass is kilogram. The unit of charge is in coulomb. What it measures, what mass measures, is a fundamental amount of gravitational stuff. Mass is having mass, where the gravitational force is coming from. It is coming from mass. It is coming from mass. Okay, where the attraction of um, charge come from? It come from the electrical stuff. It is coming from. It is a fundamental stuff of electric stuff. Fundamental amount of electrical stuff. Now, here I am going to talk about the gravitational field. Here I am going to talk about the gravitational force. Here I talk about the electrical force. Both the is for unit of force is Newton. Here also in Newton. Then I am going to talk about the electric gravitational field. Here in electric field. Here gravitational potential. Here I have given electric potential. Right? See now you. Let me explain what every row. Okay, this is one mass. This is one mass. This is the earth. This is another. This is another mass. What will happen when we bring a mass here in this around this area? It will attract. When I bring mass here, both will get attract each other. It will attract. If I bring the mass here, it will attract. Wherever if I bring mass, it will affect. So the attraction will be towards the center of air, don't like that. If you keep the mass like that, this alone will fall down. Don't like that. If you keep the mass here, this also will fall down. It will be attracted, not falling. This is attracting. Wherever we keep the masses around the earth, it will attract everything. See. That's what they have given you. Gravitational force is given in Newton. Attraction between gravitational stuff. See, mass is the gravitational. When there is a mass in the space, that will acquire and that gravitational that will exhibit gravity around its surface. Okay. Now, this is charge. Now I am going to compare this one for the electric force. See, this is a positive charge, a big number of big quantity of positive charge. This is also a big quantity of positive charge. When you bring like that, this will repel one another. But whereas in nature, every masses will get they attract each other. There is no repulsion in the nature. Any one mass will not repel another mass, right? But whereas in electricity, even though the electricity have the mass, but we take the tendency, that is a property of charge, that attraction repulsion, due to more number of when there in an atom, when there is equality of proton and electron get disturbed, it will acquire charge. See, this is a positive charge. This is another positive charge. This will repel each other. This will repel each other. This is negative charge. This is also negative charge. When you bring it together, this will repel each other. This is positive. This is negative charge. When you bring together, it will attract. When it comes very closer to closer, the attraction will be more. When we separate the distance between them, the attraction will be less. Will less. It will goes on decreasing. Depend upon the distance. See, this is attraction or repulsion between electrical stuff. Then I am going to talk about gravitational field. The unit of gravitational field is given in the unit is Newton per kilogram, whereas the electric field, the unit of electric field is Newton per coulomb. Newton per coulomb. What they define as, see, What the formula for this one is force per unit mass. Force per unit mass. Now I take it. This now I am telling you that there are some, around the earth there is electric field, there is a gravitational field. How we'll understand that there is a gravitational field around? How they define gravitational field? See, this is here. Around this space, there is some sort of field. There is gravitational field. If you bring something here, any object here, it will get attracted towards center of the earth. Okay, that means when you bring some, see, this is one mass, unit mass. The force on this mass, force per unit mass, force per unit mass is called gravitational field. Force, it will exert some force on this one. So the force per unit mass. What about the electric field? This is a proton. No? This is a proton. This is proton, a big charge of proton. This is only one proton. Around this charge, there will be some field, electric field. How you will understand? When you bring this one charge will experience some force. That is defined as electric field. So when you bring a proton here, it will be repelled. It will be repelled. But whereas when you bring electron, it will be get attracted. When you bring electron here, it will get attracted. So around this space, there is a electric field that is called force per this charge, force per unit charge. Then we are moving to a gravitational potential followed by electric potential. What is the gravitational potential? What is the unit for joule? The unit is joule per kilogram. Joule can be written as Newton meter. A unit what is force as the unit of force? The unit of force is Newton. So force of distance is in meter. So Newton meter can be written as joule. How we got Newton meter? It is defined as force time distance. Force time distance. So what we do now? We are applying some force and we are taking this mass to some height. When we apply some force, we can raise this mass. What will happen? If you leave it, it will fall down. It will fall down and exhibit some energy. So when you increase the height of this mass from the earth, you should do some work. Then it will move some distance. You should do some work. So that's what we have given here. Work is equal to force time distance. Work is equal. What is the electrical force? Electrical force can be given as EQ, whereas gravitational force is given like the see force is gravitational force is this mg times d or mgh. If you take this mass above the surface of the earth, or above here, then this d can be replaced by h, mgh. This is called potential energy. It can be called potential energy. What does it mean? It has some the potential means the ability to do work. If you leave it, it will be converted into it will start to convert into kinetic energy. It will kinetic energy. When it fall down, it will change into some other energy. Okay, mgh. Come to the here. What does it says? Electric field means force. Electric field means force per charge. Force per charge. So force is equal to, you take this q to left hand side. So F is equal to EQ. So work is defined like this. Work is equal to force time distance. So electric force, electric work is equal to EQ times distance. So how they have defined electric potential? Electric potential means electric potential energy. Work is otherwise called energy. So energy per charge. Energy per charge is called V. See, V is equal to W energy, potential energy per coulomb. What up here? How we can call it gravitational potential? That this can be written like that. Gravitational potential means mg h over this potential energy per mass. Here they have given like that. See What is potential? Electric potential energy per coulomb. What is electric potential energy? E times D. This is the work, or otherwise called energy. Yeah? This is E times D over Q. Here mgh over M. With this knowledge, we will start talk about voltage. This is called voltage. This is called voltage. Now I am going to explain you about voltage in the next video. Next video.